So in the modern world, we have a tendency to layer abstraction upon abstraction upon abstraction to where we can't understand what's going on in the code. And that is a tendency that I personally really hate. I really want to understand what's going on. So today we're going to take a look at some assembly. We're going to write our own program in assembly. We're going to compile it with Clang. We're going to run it. This is on Linux. Some of these things are going to be slightly different if you're using a different operating system. We are going to be writing x86-64 assembly, which means it will only run on a CPU running x86-64, but the concepts still largely carry over. So the first concept we're going to introduce is something called a section. A section is part of our program, and the first section we're going to talk about is text. Text is the main body of our program. It's where our code goes. We're going to define a global named start. Start is the name of the function that will be called when a program starts. That's its name. Now you might be used to seeing a program named main, a function named main, which normally when you are compiling, say, C or Zig or Rust or whatever, the compiler will actually write a function named start for you, which does whatever setup the runtime needs, and will then call main from there. Now, we're not going to be writing with any runtime, so we are going to write our own start function. So you define a function by creating a label. A label is some text followed by a colon. And the first thing our function is going to do is we are going to do a system call to end our program. So in assembly, you don't have variables the way you're used to them. You have pointers to memory, and you have registers. And registers are kind of general purpose variables. A lot of operations on your CPU are designed to work directly with registers. We're going to make a syscall, which is going to look at specific registers. The first thing we're going to do for that is move some data into those registers. So we're going to move the value of 60, which values in AT&T syntax, which is what we're using here, start with a $sign. We're going to move, I should also specify this Q here is for quad word. So this is a 64-bit integer, essentially. So we're moving that into the register, RAX register start with the $sign. And when we make a system call in Linux, it is going to look at register RAX to see which system call we are making. 60 in this case is the exit system call. We then need to give it our exit code, which in this case is going to be 0. And we're going to put that in RDI. We're then going to syscall. Okay. We're going to compile this. A quick note on how we're compiling this. We're using Clang. We're naming the output main. And we're also specifying no standard lib so that Clang does not try to give us the whole C runtime. Then going to run that, and we see we get no output, which is exactly what we were expecting. Now, if we go back over here, and we change this to 1, this is essentially saying exit with error code 1. We're then going to recompile it, run it, and then we're going to echo the error code, which is 1. Probably want to do something a little more useful. So we are going to add a new section here named read-only data. we're going to put a message in here, which is going to be an ASCII string. We also are going to calculate the name, or the length of the string. We're going to have the compiler do that for us. This is the built-in way to calculate length. We say start at the location we are, count backwards to the address of message, and the compiler will do that for us, and anywhere we have message length, it will put that value. Okay. We're going to create a function named print, and we're going to set up to do a system call. So the system call number that we need here is going to be 1, and again we're going to put that in RAX. And the next thing we need is a file descriptor. On Unix-like operating systems, everything is a file. And every file has a file descriptor, and every file descriptor is a number. So file descriptor 1 almost all of the time is going to be standard out. So we're going to put standard out into RDI. The next thing we're going to do is we are actually going to load the address of message into RSI. And then the last thing we're going to do is put the length of our message in RDX. We're then going to do syscall. Then we are going to call our function with the call keyword, call print. We're going to compile, and we're going to run. And that is essentially a hello world in assembly.